Welcome to Wisdom Academy. Now we're going to take a look at the periodic table and the electrons as it were in the periodic table. Now, periodic table, it's a table that shows the list of all the elements and how they've been arranged in rows and in columns. Now, the arrangements in rows we call the periods, and the vertical arrangements we call the columns. The row arrangement means the horizontal arrangement, like this. This is period 1, hydrogen and helium. Period 2, lithium, beryllium, boron, carbon, like this. All of these are in period 2. This is period 3, starting from sodium, magnesium, aluminium, silicon, phosphorus, like that. This is period 3, this is period 4, this is period 5, this is period 6. Now, this is the vertical arrangement, which is which we call the groups. The groups, this is group 1, this is group 2, this is group 3. You will see that there is a big gap between group 2 and group 3. The elements here, we name them, we say they are transition methods. We're going to talk about transition methods later. So, but in any case, this is group 1, this is group 2, this is group 3, and this is group 4, this is group 5, this is group 6, this is group 7, this is group 8. Now, all the elements are arranged in periodic table according to the atomic number. Now, the columns of elements in the periodic tables are called the group, like we said, and the rows are called the periods. Okay, now electrons in period 1. Let's take a look at electrons in period 1. If you take a look at electrons in period 1, we have two atoms, which is hydrogen atoms and helium atom. So let's take a look at how many electrons do hydrogen atom has. It has only one electron, because the number of proton is 1 and the number of atomic number is 1. And then the helium has 2 electrons. Why? Because atomic number of helium is 2 and the number of proton is 2. Therefore, the number of electrons is 2. So if you take a look at period 1, the total number of electrons in period 1 is what? 3, right? We have 1 for hydrogen and we have 2 for helium. Okay? So these are the electrons in there. These are the number of electrons in period 1. Now we say, why are there only 2 elements in period 1? That's the big question. Why did we not fill up period 1 with other elements? Why do we just put hydrogen and helium in period 1? Now, the reason be that the first shell can only hold a maximum of 2 electrons. So period 1 only includes the elements hydrogen and helium only, because only out of these 3 we can get 2 electrons that we need. We cannot begin to put other elements, because the maximum electron in the first shell is 2. Is that okay? So that's great. Now let's take a look at electrons in period 2. Now, what are the electrons in period 2? In period 2 we have atoms such as lithium atom, beryllium atom, boron atom, carbon, nitrogen, oxygen, fluorine, and neon. Now, if you take a look at this, elements in period 2 all have a complete first shell. Why? If you take a look at them, because the atomic number is greater than 2 and above. It's like 3, 4, 5, 6, like that, starting from lithium. So it's greater than 2, 3, 4, 5. So therefore, it means it has 2, which is for the first shell, and then 1, which goes to the next shell. For the other element, 2 for the first shell, 2 go to the next shell. Therefore, for the other element, 2 for the first shell, which is always constant for the first shell, maximum number must be 2. The maximum you can take is 2. 2 for the first shell, and then 3 goes for boron, 3 goes for the outer shell. Therefore, carbon, 2 for the first shell, which is this 2, and 4 electrons are spread in the outermost shell, because the atomic number is 6. Now, for the next shell, which is nitrogen, 2 for the innermost shell, which is closest to nucleus, and 5 in the outermost shell, because the atomic number is 7 and the number of electron is also 7. So if you look at the electrons, 2 plus 5 is 7. So this is how they are arranged. Then you take a look at oxygen. The number of electrons in the innermost shell closest to the nucleus is 2, and 6 electrons orbit around the shell in the outermost shell. Now this means that 2 plus 6 is 8. So there are 8 electrons in oxygen because the atomic number is 8 and the number of protons is 8. And don't forget, we say number of protons equals to number of electrons. So if number of protons equals to number of electrons, it therefore means that this is well represented. Now let's take a look at fluorine. Fluorine has atomic number or number of protons is 9, which it therefore means number of electrons will also be 9. But how are they represented? How are they arranged? The first 2 electrons are found in the innermost shell. They are found closest to the nucleus. Now the other 7 are found in the outermost shell. Why are all 7 being put in the innermost shell? Because they've not exceeded the total number of electrons, that maximum number of electrons that outermost shell or any shell can hold. If it goes beyond 8, it therefore means we cannot put all of them here. It goes to the 3rd energy level, which is the 3rd shell. Okay, so let's take a look at neon. Neon has 2 in the innermost and 8 in the outermost, so its balance is complete. The number of electrons is complete. So this is for the 2nd period. So for the 3rd period, we'll start having the 3rd shell. For the 3rd period, it therefore means the number of period determines the number of shells that you're going to have in your arrangement for any atomic structure. Now let's take a look at that for the 3rd case. Now in the 3rd case, we have elements in period 3 have complete 1st and 2nd shell, but the 3rd one is not complete. Now let's take a look at this in the period 3. These are elements in period 3 such as sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Now these are elements. Now let's take a look at the electrons. The first 2 are complete, the 3rd ones are not. Now let's take the first one is 2, the next one is 8, and because sodium is 11, which is 2, 8, 1, we have 2 in this shell, 8 in the 2nd shell, and 1 in the 3rd shell. For magnesium, same thing, 2 in the first shell, 8 in the 2nd shell, and 2 in the 3rd shell. For aluminium, same, 2 in the first shell, 8 in the 2nd shell, and 3 in the 3rd shell, because it's 30, atomic number is 13. Then for silicon, 2 in the first shell, 8 in the 2nd shell, and 4 in the 3rd shell, because the atomic number is 14. And then for phosphorus, we have 2 in the 4th shell, 8 in the 2nd shell, and 5 in the 3rd shell, because the atomic number is 15. 2 plus 8 plus 5 is 15. For sulfur, we have 2 in the 4th shell, we have 8 in the 2nd, and we have 6 in the 3rd shell. So the atomic number will be 16. For chlorine, same thing, 2, 8, and 7, because the atomic number is 17. For argon, it's 2, 8, and 8, which completes the shell. So if you take a look at the pattern, it starts from 281, 282, 283, 284, 285, 286, 287, 288. Now, beyond this, it goes to period 4. It will now be 2881. That will be in period 4. In period, remember, in period 2, we have 21, 22, 23, 24, 25, 26, 27, 28. Then the next electron goes to period 3. Now, in this case, after period 3 is completed, the next electron goes to period 4. Okay, great. This is how electrons are being arranged in the periodic table and in the atom. Now, let's consider the electron arrangement in the first 20 elements in the periodic table. Now, these are the groups. Group 1, Group 2, Group 3, Group 4, Group 5, Group 6, Group 7, Group 8. These are the arrangement. Now, this is period 1, period 2. Period 2, you see, when it gets to 8, any electron beyond 8, it goes to the 3rd period. It becomes 281. So, it starts from 221. At first, it was 1, then 2 completes. The next one goes to 21. 22, 23, 24, 25, 26, 27, 28. Any other electron, it goes to the third one. 281, 282, 283, 284, 285, 286, 287, 288. Then any further electron, it goes to the fourth one. 2881, 2882, 2883, 2884, 2885, and so on and so forth. So this is how the periods are being determined. It means the number of period determines the number of electrons that the atom will have. So if we know the number of atoms or the number of electrons, we can simply tell the number of the period it will belong to in the periodic table. Is that okay? Great. If this is understood, now let's go down to the group. As we go down, electron threads in the periodic table. Let's take a look at threads down a group. Now, the number of outer shell electron is the same as you go down the group. Now, the number of complete electron shell increases by 1 as you go down the group. And the number of a group is the same as the number of electrons in the outer shell of electrons of elements in the group, except for group 0 or group 8. Now, threads across the period. This first connotation is for threads down the group as you go down the group. Now, what if as you walk across the period, as you look at the element across the period, the number of the outer shell of electron increases by 1 as you go down to the next period, across the period. You go to the next period, it will increase by 1. And also, the number of complete electrons share stays the same. The number of complete electrons share for the same period stays the same. Okay, so these are the basic things we need to know. Now let's take a look at the periodic table. Now we can take a look at the periodic table and begin to look at the elements in group 1, elements in group 2, elements in group 3, elements in group 4, group 5, group 6, group 7, group 0, group 8. Now for group 1, these are the elements in group 1. We have hydrogen, lithium, nitrogen, sodium, potassium, rubidium, cesium, frescon. So these are the elements we have in group 1 in the periodic table. And this is they all end with 1. If you look at the electronic configuration or the structure, it will end 2-1, 2-8-1, 2-8-8-1, 2-8-8-8-1, 2-8-8-8-1, 2-8-8-1, 2-8-8-8-8-8-1. It will continue to end with 1 because they are in group 1. This is why they are in group 1 in the periodic table. This is why they are in group 1 in the periodic table. Now let's take a look at elements in group 2. For elements in group 2, they will continue to end with 2. The number of electrons will continue to end with 2. 2-2, 2-8-2, 2-8-8-2, 2-8-8-8-2, 2-8-8-8-8-2, like that to continue to end with 2 for elements in group 2 in the periodic table. And these elements are beryllium, magnesium, calcium, and so on and so forth as it